I'm grateful and really excited to hop on probably my favorite soapbox and talk to you today about genetic sequencing and its role in diagnosis. So hopefully by the end of my rant, hopefully it's not too ranty, you'll get kind of why I believe that the limited use of sequencing in a clinical setting is maddening and something that should be expanded. So I am not a scientist. I'm actually a mother, and I'm going to leave to brighter minds than me going into the differences of all the different kinds of genetic sequencing, like whole genome versus exome. I'm not going to go into that, but I am going to share some of my family's story with you and use it to illustrate how genetic sequencing can be a powerful force for driving a diagnosis, and how that diagnosis can lower healthcare costs, or at least it did in the case of my family, and I believe it lowers healthcare costs for society overall, and how sequencing can help find treatments, improve subsequent care, and quality of life for patients and their families. So this is my son, Bertrand. I'm going to slip and call him Buddy, most likely, because he's everybody's friend, with the disclaimer that this journey is not unique to him. You're going to hear this many times over, but there's rare disease affects 1 in 10 individuals in the US and around the world. There's over 7,000 of them, and actually because of sequencing and the success that we've seen, that number is growing. We're finding more and more that conditions like autism, cerebral palsy, heart disease, epilepsy, all of these things are actually driven by individual genetic mutations. And that's really important because treatments aren't one size fits all. So once you're able to identify an individual's specific, genetic drivers for their disease, you're able to target treatments for that person individually. I think this is the premise behind the precision medicine initiative. So, more baby pictures. I said I'm a mom. Buddy was born on December 2007. He quickly started baffling doctors. They couldn't pinpoint why he had a movement disorder, some developmental delays, seizures, a lack of tears, but unfortunately, given the progression of his symptoms, by about 14 months old, I was told that he had a 2 to 3 year life expectancy, but they couldn't tell me why. That's not something you want to hear when you're a mother or a parent or anybody. So I did what any mother would do. I packed up my child and started crisscrossing the country for answers from my son. And then, basically from 2008 until 2012, doctors ran dozens of genetic tests and panels looking for known conditions that my son could have. They also ran, seriously, a countless number of EEGs, MRIs, CT scans, lumbar punctures, skeletal surveys, liver biopsy, skin biopsy, muscle biopsy. They did them on me too. I have the scars to prove it. Everything that they could do to try to figure out my son's diagnosis. Unfortunately, he also received symptoms for things such as seizures at that time that almost killed him, because we would eventually learn that these treatments were not correct. Given his underlying condition, of course they would kill him. So it's things you know in hindsight. But when we basically exhausted all the traditional avenues of trying to diagnose our child, I was obsessed with this new thing called sequencing. It was in the news everywhere, this Human Genome Project. It's amazing. We've gotten the cost down. I was I need this for my kid. So finally, we got him into a study, and this was the earliest study. It was 2010 on the clinical applications of exome sequencing, and it was a study being done by the fabulous folks at Duke. And they would do something called trio sequencing, where they would take my son, me, and my husband, and basically see what's different in him, and if they could identify what was the driver for his disease. And I'm very grateful to Vandana and David Goldstein and all of those folks because after 4 long years, they were able to identify that he had a tentative cause for his disorder. And we're the lucky ones, because only 4 years. That's the average rare disease patient goes at least 7 years before they find a diagnosis. So they identified this gene called NGLY1, and as you can see, he doesn't have it. It's a highly conserved gene, which means yeast and fish and All sorts of animals have it, so if they have it, it's probably really important and you probably shouldn't be missing it. And this is the paper that came out of that initial study. And what I think is really phenomenal, because this is the early days, this is back in 2012, you can see that they were able to diagnose 50% of the kids. And these were really hard to diagnose kids. These were kids that had already exhausted all other traditional means. And since then, there have been dozens of studies that have proven, like I hear numbers between 30% and 60% of these really hard to find, really hard to diagnose cases being diagnosed through sequencing. So it's really phenomenal. The other thing that's really phenomenal is that a lot of these studies also include some of the costs associated with prior testing that's been done on these kids. And in my son's case, maybe I didn't mention it, he was the first and only patient ever known with this particular disease. That's not something you pick up on your typical panel or any other sequencing, any other kind of testing. That's something that you could only really find through sequencing. And there's a lot of kids like him, because thanks to this sequencing technology, that you are finding these oddball cases where you have these first and only. So hopefully I've convinced you that sequencing can help diagnose patients. Now I want to talk about some kind of hard things, because I hear in DC that people like numbers. So we spent over $25,000 on simple genetic panels before he got diagnosed. That's a fair amount of money. Then in other diagnostics, over $100,000, because MRIs, CT scans, lumbar punctures, muscle biopsies, liver biopsies, especially when they're done under pediatric anesthesia, are not cheap. Then there was the $250,000 spent on prolonged ICU stays from incorrect, inappropriate care. Unfortunately, other NGLY1 families haven't been fortunate to get that information in time. And coming from Utah, where I lived for the past 9 years, unfortunately, I know multiple families with 3 or more kids suffering from the same genetic disease. I know one with 5. 5. And I think it's unconscionable that someone hasn't said, okay, like, Medicaid won't cover it. But you'll cover the hundreds of thousands of dollars in other testing and care, but the one thing that could potentially diagnose them and point the way to treatment or to how to minimize their costs, you won't pay for that? I mean, I think there's like $1,500 and $10,000 and $1,000 genomes now. So a trio is like $5K. Seriously, that's a drop in the bucket compared to the costs. Anyway, sorry, that was the ranty portion of this, apparently. I just don't get it. I really don't. If someone can explain that to me, please find me afterwards, because I don't understand how that's good math. So I firmly believe that sequencing can lower costs. Lastly, I believe it can improve quality of life. And I say so because it has. One of the very first things after getting my son diagnosed is we found others. We have now 60 patients worldwide with my son's disorder. In that community, that support, it's improved my quality of life as a mother, because there are people I can ask. But just by exchanging information, we were able to find which anti-epileptic drugs work right away. So you stop those seizures when they're a baby, instead of waiting until they're 4 years old like my son and they've had 4 years worth of brain damage. So there's now kids who are born with NGLY1 today who can talk and walk, which are things that I am so happy that are now possible thanks to that initial sequencing and that diagnosis that we were able to have. I wish it could have been possible for my son, but I'm glad that other families don't have to deal with that. You can read more about that initial thing in here, but within weeks of that initial diagnosis, we flew out to a lab in California because there was no FDA-approved treatment for my son. We started doing science, because science is awesome. And so science becomes action when there's nothing else. And science then becomes medicine, which is really exciting. I'm happy to say we now have assets for screening. We have animal models, we have a urine biomarker, and we have 4 distinct treatment pathways. And I have to give a shout out to Retrophin if they're in the room, because they've been fabulous. Yeah. In developing these for our kids. And this is a disease that's only 5 years old at this point. It's amazing. And I have to give a special thank you, since we're on Capitol Hill, to the National Institutes of Health, because let's say none of this would have been possible without the Human Genome Project, without all of those investments in basic research that happened over years, decades, to form the tools and the knowledge base necessary to, understand my son's disease. And I was going to pull out all of these slides because I think I'm over time, but we were involved in a natural history study for my son's disorder. And it goes by very quickly, but what's really cool about this is at the end of this, they found something really neat, which is what happens when you have rare diseases. You find really cool things. Maybe I shouldn't say that. Is that like insensitive? But it is cool. They found that our kids were oddly resistant to certain kinds of viruses, which I think is weird. And then other researchers elsewhere started looking into this too. So things like HIV, Ebola, hand, foot, and mouth. There you go. For some reason, they're resistant to this. So this is like what they're looking into for the next potential generation of antiviral medications. So yay for research. It's awesome. Yay NIH. NHGRI, NCATS, I love you guys. So I just wanted to end with, obviously we are not unique in this. There's so many advocates. We're the lucky ones. The ones in this room, the ones that are still standing, capable, alive, able to speak and advocate. We're here because we're the voices for those of us who are bedside at the ICU, and it can't be her. So thank you for listening, for making this possible, and hopefully we'll hear more success stories like these going forward, especially when sequencing becomes more widely available for patients.